Okay, it's been a while since I've done a Dex video tutorial, so there's been a lot of changes since the last one. So I thought I'd go through some of the new features, and in this case, I'm going to cover something called the WebDriver. So first, I'm going to open a project here, and in this case, the WebDriver is going to be driving some WebGL content. So the first demo has a Hello World application. And what happens when you select this template is you first point over to an input template. In this case, it's a Hello World template, and these templates mix Groovy code and HTML to inject the data via Groovy, and then what happens is the Dex process data gets intermingled with that view, and then it's going to output this file over here. So hello world.html will be the output file. In this case, we're going to render it with a co-browser called Chrome. So unfortunately, the WebKit browser that comes inside of JavaFX doesn't support WebGL at this time. So what we had to do is we had to create a co-browser with the Selenium package that drives an external browser session. So it's going to send that data to the browser and it's going to render it. So let's go ahead and execute it. So hello world. So what we're looking at is a 3D world with some basic shapes and some shadows, and we can flip over to the other side of the world. Pretty cool stuff, not super useful yet, but let's move to the next demo, which is we're going to enable reflection, which is going to be just another view of essentially the same world, only we have a panoramic background and we have reflective surfaces. So pretty snazzy, shows some of the capabilities of WebGL, and if you're like me, then your mind's racing, okay, how can I incorporate these types of features into my visualizations? Because you may be able to do things that are quite stunning. So next, I'm going to enable a view called the scatter plot. So not quite as glitzy as the previous two demos, but the difference here is that this is going to actually demonstrate the fact that we're actually reacting to data that Dex is pumping into the view itself. So I'm going to go ahead and put a view data component in here just so we can see the data as it comes down. And I'm going to execute again, and you can see the data, the sine, cosine. And if I jump over to the browser, here we can see the data, the sine, cosine data, and we can rotate the world just like with the previous views, and we can pan out, pan in, and even run through the data. And then when we get really close, we see that what appeared to be the lines are really just spheres that are quite close together. So kind of cool, kind of useful. And let's move to the next view here. I'm going to disable that. We don't really need to look at that data. Next view is going to be sine, cosine, tangent, and let me back up for a second. So what this did over here in the Groovy script is it created a header, x, sine of x, cosine of x. We define an amplitude to exaggerate the features of the curves, and then here we're just iterating from negative 720 to 720, taking each as we go, and we're adding to the data 3 coordinates here: x, y, and z. X is this iterator value, sine of x times the amplitude, sine of the radian conversion of this degree number here is going to be the x coordinate, and then cosine is going to be the y. I'm sorry, the y coordinate is going to be the sine, and the cosine is going to be the z coordinate. So this is that view of the data. So next, let's stick within the scatter plot, and let's just take a look at some other stuff here. I'm going to enable that and disable the previous data set, and I'm going to hit execute, and then here we can see what happens when we add another series to it. we still have the sine cosine uh, graph there, but we've added some tangent data. It's kind of here we can see the behavior of the tangent runs off into the distance here. So one of the cool things with WebGL, and I'm using the 3GS package to simplify my interface into WebGL, is it has things like fog, and it can really create some pretty cool effects. So let's see here. I'm gonna also view positive random. Disable that, and I guess in this case let's switch over to Firefox for kicks and grins here. So let me execute, and what's going to happen is it's going to pull up a Firefox window. Looks like it's not sized appropriately, but let me resize it and let me re-execute it so it redimensions that window. Wrong browser. Here we go. Here's Firefox. So looks about like what we expected, which is the scatter plot. I'm going to switch back over to Chrome because it tends to be a little bit faster for stuff like this, though either are pretty fast, and yeah, it looks about like what we expected to see. Pretty random distribution of values throughout. And let's see. Next I'm going to, and that's positive random, so this demo is not going awesome. So you can see that everything comes out in the positive direction from the X, Y, and Z. And let's see. Next I'm going to go with a view called the porcupine chart. Let me disable this, and let's, I guess, take a look at just some basic random numbers. So I'm going to enable this data set here. I'm going to disable that one, and let's stick with Chrome, and I'm going to hit execute, and that's what it looks like in what the data looks like in this particular view. So we can scroll in, we can scroll out, and what this is doing is essentially it maps the data to a sphere, and the value, the amplitude of the line from the sphere is going to be determined by the data set. So if we send in positive randoms, what we're going to see across the sphere is instead we have just a subset of the data here. So basically it's the subset on the sphere that represents the positive X, Y, and then the Z amplitudes. So let's again take a look at sine cosine. Let's enable that, and can't remember what I'm going to see here, but it's always kind of interesting. Don't know how useful, but here we see sine cosine. So we got a it's kind of pretty. I'm not really sure what I'm looking at, but that's kind of the case with WebGL. It has so much potential, but when you move into that third dimension, you never quite know what you're going to see. At least I don't. So I'm going to put the sine cosine tangent function in here, and let's again graph it out to Chrome. And basically now we see both of those curves overlaid on each other, and that is pretty much it. And I did have one more demo here, and like the label says, it's pretty obnoxious, but I can't help it. I love it. And it's the Dex logo, and essentially what it's doing is it took one of the 3GS demos and mapped it to the Dex logo. Now what's really interesting about the spheres is they're really not spheres. I thought it was pretty interesting. Really what they are cubes that are mapped onto spherical sides, and they come together to produce the illusion of a sphere, which pretty much everything in WebGL and graphics in general is nothing but an illusion, because you're working in 2 dimensions. But and you can see how this illusion kind of falls apart when you zoom out, and these transforms aren't quite exactly right. But then when you squeeze in here a little bit, then things look pretty good when you get up close. It's pretty amazing stuff. WebGL and 3GS is just absolutely fantastic. And that is about a wrap for this video tutorial. Thank you.